Hello trigonometry students, my name is Jami Emigh, and this video is continuing our discussion on chapter 5, starting with sum and difference of two angles identities. Let's start this discussion off with something we don't want to do, which would be to see cosine of an angle A plus an angle B and think that we could potentially distribute that function to look something like taking the exact value of cosine of A, adding that to the exact value of cosine of a different angle B, and that being equivalent to cosine of angle A plus angle B. This is not equal. We do not want to do this here. I'm going to triple cross it out so we don't accidentally get tempted and do that right there. What we want to do instead is find the value of cosine of A, multiply that by the value of cosine of B, less the value of sine at that angle A times the value of sine at that angle B. Same thing goes for A minus B. Don't distribute that. Make sure you do cosine of A times cosine of B plus sine A times sine B. Here is the sum of two angles identity for sine. Here is the difference of two angles identity for sine. Here we have the sum of two angles identity for tangent. And last one, the difference of two angles identity for tangent. Let's see an example on how to use these identities. Find the exact value of cosine of 15 degrees. All right, put a little snapshot of our table here, and if we go over here to the degrees, and we look for 15, we're not going to find 15 degrees here. Why? It's not a special angle, 30, 45, 60 in any of the quadrants, and it's not a quadrantal angle. So what we want to do is think of two special angle measures whose sum or difference is 15 degrees. So we're going to use this column here, and we want to find two. Choose two whose sum or difference is 15 degrees. Go ahead and pause that video and pick two. All right, welcome back. If you came up with 45 and 30 because those have a difference of 15 degrees, nice choice. There are some other options down here as well, but I'm going to go with the 45 and 30 and use this identity, making angle A 45 degrees and angle B 30 degrees. So we set it up as cosine of 15 degrees is equal to cosine of 45 degrees minus 30 degrees. Using the identity, that leads us to cosine of 45 degrees times the value of cosine of 30 degrees plus sine of 45 degrees times sine of 30 degrees. So now we're going to use the table to plug in each of these four values. Cosine of 45 degrees right here. So that's going to get the first spot. Cosine of 30 degrees here. Rad 3 over 2 gets our second spot. Then we'll add sine of 45 degrees, rad 2 over 2. And then we'll multiply that by 1/2. All right, it looks like this here. And after that, it's really just about putting this in the most simplified form, which would be doing the multiplication first, and then we'll have a common denominator of 4 and doing the addition second. All right, let's try another one. Find the exact value of 5 pi over 12. Come over here to our table, and we're looking for 5 pi over 12 radians. 5 pi over 12 radians. If it's on here, that would be great. 5 pi over 12. It is not on here. So what we can do instead is think of two special angle measures whose sum or difference is 5 pi over 12 radians. All right, so coming over here, try to choose two of these from this column here. Choose two whose sum or difference is 5 pi over 12. Pause the video and try that now. Welcome back. If you came up with pi over 6 and pi over 4 have a sum of 5 pi over 12, nice work. It's not quite as easy to see in radians because we don't have everything with a common denominator. So I'll just show you here. This would be 2 pi over 12, adding that with 3 pi over 12. Now that we have a common denominator, that gives us our 5 pi over 12. And here's what it would look like. We're going to use cosine of a plus b. This is the sum of two angles identity. And we're going to make a our pi over 6 and b our pi over 4. That is going to be equivalent to cosine of a turns into pi over 6, b turns into pi over 4, minus sign right there. Lots of minus and fraction bars there, so it can look a little bit overwhelming. If you want to add parentheses, that might just help show the operations. These two are multiplied, then there's a minus sign, then these two product again. All right, so let's find each one of these. Cosine of pi over 6, rad 3 over 2 gets our first blank, times cosine of pi over 4 is rad 2 over 2. Then we'll do subtraction of sine of pi over 6, which is 1/2, times sine of pi over 4, which is radical 2 over 2. Plugging those in looks like this. And after this, again, it's just simplifying. So following our order of operations, we would do the multiplication first and then the subtraction second, getting an exact value of cosine of 5 pi over 12 being equal to the square root of 6 minus the square root of 2 all over 4. All right, see the next example. Find the exact value of sine of 75 degrees. All right, so you come over here to the degrees, and I'd like you to just go ahead and pause the video and see if you can get yourself through this question. Find the exact value of sine of 75 degrees. Welcome back. Let's see how you did. If you went with two special angles whose sum or difference is 75, being 45 and 30, nice job. That's their sum is 75. That would be the sum of two angles identity for sine. Plugging those in, we would have sine of 45 times cosine of 30 degrees plus cosine of 45 degrees times sine of 30 degrees. Getting the values from the table looks like this. Radical 2 over 2 times rad 3 over 2 plus rad 2 over 2 times 1/2. And now simplifying that, we would get radical 6 plus radical 2 all over 4. Right. Next one, we're asked to find the exact value of tangent of 7 pi over 12. Okay, gonna have to focus on this column this time, so we're in radians, unless you want to convert it to degrees. But if you're sticking with radians, using this column here, go ahead and pause the video and try this one now. Welcome back. Let's see how you did. Two special angle measures whose sum or difference is 7 pi over 12 radians. Pi over 3 and pi over 4, those have a sum of 7 pi over 12 radians, so that would work. Using the sum of two angles identity here, plugging in, angle A is going to be our pi over 3, angle B is going to be our pi over 4. That would look like this here, applying the identity. After this part is when we go to the table. We find tangent of pi over 3. It's radical 3 plus tangent of pi over 4 is 1 all over 1 minus tangent of pi over 3 again times tangent of pi over 4. It would look like this here. There's the radical 3 plus 1 all over 1 minus radical 3 again, 1 again. All right, last thing to do is simplify this. And one strategy, as we've worked with this before, one way to simplify this would be to take the conjugate of the denominator and multiply top and bottom by it. So the conjugate of the denominator is 1 plus radical 3. Make sure to multiply that top and bottom so that we don't change our value. So it's going to take some distributing. It's a binomial times a binomial, so some people call it FOIL. So distribute once, and then for our denominators, we'll have to do second round of distribution and simplify, and we will get 4 plus 2 radical 3 all over negative 2, but I can see all three of our terms have a common factor of 4 there, so we would take that down to 2, 1, 1, and dividing by negative 1 is where we get the negative 2 less radical 3 over positive 1, which we don't write. Okay, let's reverse the process. We're going to use the identities in the opposite way that we were using them before. So this time we're asked to find the exact value of cosine of 87 degrees times cosine of 93 degrees minus sine of 87 degrees times sine of 93 degrees. So we might think, well, let's go to the table. What do we have in our list here of degrees? And we won't find 87 or 93 there. But we do, hopefully, we recognize that we have a identity here, and it's of the form cosine of 87 plus 93 being equal to, see, match it up like this. Cosine of angle A, cosine of angle B, it's a minus sign that we're going to use, sine of 87 and sine of 93. So this is the, it was either the first or the second identity on our list. Using that, we would just take angle A, making it 87 degrees, angle B, making that 93 degrees. We can add those together, which is 180 degrees, and this we do know the exact value of. It is right here, negative 1. So the sum and or difference of two angles identities can be helpful whether we're starting with the left side of the way we saw the identities or the right. Try this one. Pause the video and give that a try now. Welcome back. If you decided that this looks like the difference of two angles identity for sine, nice work. See, it matches up. Sine, sine, cosine, cosine, subtraction, cosine, and then sine again. Then we apply that. We take our 40 and our 160 degrees, making them angles A and angle B. Their difference is 120 degrees. But in this order, we've got sine of 40 degrees minus 160 degrees. So that would be negative 120 degrees. Well, we know that, let's see. Well, let's pretend you go over here at that point. And you're like, well, what is sine of negative 120 degrees? It's not here, but we know the odd and even identities. So we know that sine being odd means that we can find sine of 120 on our table and just do the negative of it. So let's do that. Sine of 120 degrees is right here. Radical 3 over 2, which makes sine of negative 120 degrees negative radical 3 over 2. Double angle identities. Double, so multiplying by 2. So here we have tangent of double whatever sum theta is, cosine of double sum theta, sine of double sum theta. Here's another form for cosine and a third form for cosine. So you can take one of them and using your identities develop all three, but these three are frequently used, so we've got all three listed there. Only one that we really list out and use for tangent and one for sine. All right, that being said, say we're given an example like cosine of theta equals 3 over 5, and we're told that sine of theta is less than 0, and our task is to find sine of 2 theta. All right, let's find an identity for a double angle of sine, because that's what we're being asked to find here. And sine, we only got one choice. We got this form right here. Okay, well, to find sine of 2 theta, we know that that will be equivalent to 2 times. We're going to need sine of theta, and we'll multiply that by the value of cosine of theta. So we're going to need sine of theta and cosine theta. Cosine theta, we've got, it's right here, it's 3/5. So that will be that will be our 3/5, but we still need sine of theta. So taking our identity, double angle identity, turning it into a blank template, we need sine of theta to go here. We don't have it yet, so we're going to do some side work. And then we'll multiply that by the 3/5, which was given to us. All right, side work to find sine of theta. Well, based on what we know, we can use the Pythagorean identity, sine squared theta plus cosine squared theta equals 1, because we know cosine theta. So we plug in its value of 3/5, and now we are going to isolate sine of theta. So we will square this top and bottom. That gives us 9/25. Then move that term to the other side of the equal sign using its inverse operation, subtraction. Here we are now doing the next few steps to isolate sine of theta. Find a common denominator. This would be 25 over 25 minus 9/25. So that would be 16/25. And then square rooting both sides of the equal sign. Remember that if we introduce the square root, we need to address the positive and the negative root. That gives us square root of 16 over 25 gives us 4 over 5, and we are going with the negative root. How do we know to go with the negative? Because right here, we're told the condition that sine of theta needs to be less than 0. All right, so lots of side work there, and that was all for us to find this blank right here. After that, we can just simplify what we have here, and we will have the value of sine of double some angle theta. Looks like that. Multiplication gives us negative 24 over 25. Oh, this shouldn't be here yet. Let's see what that's all about. All right, we're asked to write 4 cosine of 75 degrees times sine of 25 degrees as a sum or difference of 2 functions. Okay, for us to do this one, we're going to need to use what's called a product to sum identity. That's where you're literally taking a product like this here. Check this out. This is cosine A times cosine B. You're taking this product and you're changing it into a sum. So we call it product to sum. Going from product to sum right here, okay? And we can do that, we can use that for our expression given to us for cosine of 75 degrees times sine of 25 degrees. We want to find which of these match what we've got going on here. We've got cosine of angle A times sine of angle B. So that is going to be the bottom one right here. So this is the one we're going to want to work with. Okay, so it turns out that, let's take our 4, that's where this 4 came from, and we're going to multiply that by the equivalent form of cosine of 75 degrees times sine of 25 degrees. So it's like putting the 4 out here, 4 times all of this, if you're wondering about this right here. You know what, I would also like to put in parentheses, a bracket like that. So we have 4 that came from here And now we're changing this into this using the product to sum identity. And doing some simplification here inside the parentheses, that gives us 100 degrees, and over here we've got 50 degrees. Distributing our 4 gives us 2 sine of 100 degrees minus 2 sine of 50 degrees. Here we have an example where we're asked to write this double angle less sine of 4 times theta as a product of two functions. Sine of 2 theta minus sine of 4 theta is currently a difference. You can see right here, we're looking at the difference of those two functions. And so we would want to pick one of the following identities. And these ones are called sum to product, because that is what they do for us. When we have the sum or the difference of two functions like we have here, we can change it from a sum into a product. So that's why it's called sum to product identity. This one would look like this: 2 times sine of angle A plus angle B, half of that, times cosine of angle A minus angle B, half of that. So we need to pick one of these, and we are working with a difference. We've got sine, minus, and another sine function. So we would want to go with this one here. All right, we're going to use 2 theta for our angle A and 4 theta for angle B. So wherever we see an A, we're going to substitute 2 theta. Wherever we see a B, we're going to substitute 4 theta. We'll do that here and here, and then we'll reduce. That would look like this: 2 cosine of change angle A into 2 theta plus change angle B into 4 theta, half of that, times sine change angle A into 2 theta less change angle B into 4 theta, half of that. Simplifying, 2 thetas plus 4 thetas is 6 thetas. 2 thetas minus 4 thetas is negative 2 thetas. We can reduce here the 6 and the 2, the negative 2 and the positive 2, giving us 2 cosine of 3 theta over sine of negative theta. Well, we know our even and odd identity would make that negative twice cosine of 3 theta times sine of theta. So what we've done is taken it from the given sum right there to a product. All right, this time we're asked to find the exact value of cosine of 15 degrees, but very specifically, we're being asked to use the half angle identity for cosine. All right, and here's how we will do that. We're going to think of a special angle measure that when divided by 2, hence the half angle, is equal to 15. Well, that would be 30, because 30 degrees divided by 2 is 15 degrees. So now we're going to pick one of the following half angle identities. See how this is half of angle A, half of angle A, half of angle A, half of angle A, and half of angle A. And for these ones, one option for cosine, one option for sine, 3 different options for tangent. One is typically easier than the others, just dependent on our information. So let's pick one. We're being asked to find the exact value cosine of 15, so we want to go with this one here. Except instead of the angle A, we're going to use 15 degrees. Oh, my mistake. We are not using 15 degrees, we're using 30 degrees because we need it to be 30 degrees divided by 2, which will be our requested cosine of 15 degrees. All right, so we set that up as plus or minus the square root of 1 plus cosine of 30 degrees all over 2. That came from this right here, just 30 degrees. I don't see the plus or minus on the root there, so why are we not considering that? Negative root. Reason, because 15 degrees, terminal side lies in quadrant 1, and we know that cosine is positive in quadrant 1. So that's why we've just got the positive root here. All right, let's simplify this by taking the value of cosine of 30 degrees from our table, being radical 3 over 2 in for cosine of 30 degrees. Looks like this here, and that simplifies to the square root of 2 plus radical 3 all over 2. In this example, we're asked to find the exact value of tangent of 22.5 degrees using, and very specifically, they want us to use this half angle identity. Okay, to use that, we would need to think of a special angle measure that when divided by 2 is 22.5 degrees. So we go over here, any of these values here, that when divided by 2, we get 22.5 degrees. Hopefully you came up with 45 degrees. 45 divided by 2 is 22.5. And now we'll use the identity requested. Changing angle A into our selected 45 degrees, sine of 45 degrees over 1 plus cosine of 45 degrees. Now let's plug in the values of these. Sine of 45 degrees, radical 2 over 2, over 1 plus cosine of 45 degrees is radical 2 over 2. That would look like this here after substituting them in. Next step, the thing you see right here is just a process called clearing the fraction. If we multiply by 2 over 2, it will take us to this, radical 2 over 2 plus radical 2. The thing you see following that is the process of multiplying by the conjugate to help us simplify. Remember, for this one, we're going to have to use distribution of a binomial times a binomial. For the numerator, it's a monomial times the binomial. So take your time with all of those. And if you do that correctly, we'll get to 2 radical 2 minus 2 over 4 minus 2, which these all have a factor of 2. So if we take that factor of 2 out, we're left with radical 2 minus 1. And that is the end of our chapter 5 discussion. Please go to homework numbers 31 through 55. My name is Jami Emigh. Thank you for being here, and I will see you next time.